The migration to AV over IP is finally here, and with so many hardware solutions being made available to us, the need to feel confident in how these solutions are implemented has never been greater. We all know the importance of design, from single building infrastructures to highly complex systems distributed across multiple locations. To begin installation without any kind of design or planning is considered ludicrous, and AV over IP is no different. This video will explore the design changes which support this new architecture and demonstrate the significant simplifications possible compared to older matrix switch based designs. Let's start with the traditional hardware-defined approach which has serviced many integrators well for many years. A matrix switch at the centre, surrounded by transmitters, receivers and specialised multi-view processors, video wall processors and scalers ensure the original video content is processed and displayed perfectly across multiple displays with zero latency. Systems like this have historically worked well, but we can already see complexities in the design topology which makes troubleshooting difficult and time-consuming. Proprietary systems like these are also very expensive and not very scalable. However, they do ultimately give us exactly what we set out to achieve: the original video quality delivered across multiple displays with no latency. Of course, the challenge with hardware-defined solutions is that redefining their function means changing out the hardware. As the user of the system's needs change, the only way to adapt the system is to change out pieces of equipment at great cost. Without this expensive upkeep, the system could become stale and fall into disuse. Here we have a much simpler SDVoE architecture which guarantees the same service without any compromises. The functionality of this system is identical to the hardware-defined system we previously examined. However, its architecture is much simpler. Each source attaches to an encoder. Each display attaches to a decoder. A 10 gigabit switch sits in the middle and connects all devices. Now, software takes over to tell the system what it is: a matrix switch, a KVM switch, a multi-view processor or a video wall, or maybe a combination of all of these things. Whatever application you need today can be changed tomorrow with some minor reconfiguration of the software. We call this software-defined video. This new architecture means that everybody in the chain will benefit. The system designer saves time, the system installer saves headache, and the end user can enjoy a flexible system which can easily adapt to any environment. This adaptability is also a form of future-proofing, as now adding new functionality or changing the system's behaviour is much more affordable compared to the hardware-defined approach. In this architecture, there are fewer devices, fewer types of devices, and fewer signal exchanges, which means there are fewer points of failure. This often results in significant reduction in costs for many system designs. AV over IP architecture supports growth without the need to replace expensive hardware. If the distributed system needs to be extended to further areas, a simple wiring infrastructure will allow stackable network switches to send packetized data to many more endpoints with little or no disruption to the existing infrastructure. Once again, this simplified design results in a much more cost-effective solution when expanding the system. As system designs become more and more complex, with the need to distribute AV over multiple floors or even buildings, an SDVoE infrastructure will ensure an extended system life with greater redundancy. SDVoE will always keep 1 gigabit of bandwidth free for data, a concept we call IT over AV. The ecosystem of tomorrow is here today. Through SDVoE, Ethernet infrastructure can now promise everything the traditional matrix switch did and more. And thanks to tried and tested network technology constantly expanding, the future truly lies with software-defined video over Ethernet. To discover more, visit SDVoE.org.